Just like when we were working with arithmetic sequences, we had a special rule to find any term or the nth term in a sequence. Now with geometrics we have a rule, but it is quite different to the rule that we are used to. So Tn equals a times r to the power of n minus 1. Again, most of the things you are familiar with. A is the first term, r is the common ratio, and n is the term or the position of the term that you are looking for. So if we have a look at this example here, it says find T15, which is the 15th term in the sequence 3, 6, 12, 24. Now obviously we could put that into our calculator and keep going and generate a sequence, or we could do it manually, but obviously it's going to be much quicker to use the rule, especially if the question had said find the 100th term. So what do we know here? We know that A is equal to, or T1 is equal to 3. We can also see here that R is equal to, because we are told it's a geometric sequence, so it doesn't matter what pair we take, 6 over 3 or 12 over 6, 24 over 12. So our common ratio is 2, so we are multiplying by 2. We know that we're looking for T15, the 15th term, which means that n must be equal to 15. So let's substitute that into our rule. So that's our rule, and so T15 is equal to 3 times. Now that r is the only thing that's to the power of that, so I'm just going to put a bracket around that. 2 to the power of n minus 1, which would be 15 minus 1. And when we work that out in our calculator, it comes out to 49,152. So what we have actually found there is the 15th term of that sequence which begins with 3, 6, 12, 24. Now this can be a little bit tricky. What we need to do first of all is convert our percentage change into a R value. Okay, so how do we go about doing that? Well, these two are the best ways of remembering it. I would have these in my notes. So a P% increase, R is going to be equal to 1 plus P on 100. Or if it's a P% reduction or decrease, R, our common ratio, is equal to 1 minus P on 100. A really good explanation of that would be this. A 10% reduction means that there will only be 90% left. In other words, each new term will be 90% of the current term. So that's why we would use R is equal to 1 minus 10 over 100 to give us the 0.9. So let's put that into an example down here. So 1, we're going to find R, and 2, we're going to state correct 2 decimal places the first 4 terms in each of the following. Let's see what information we've got. Well, we're looking for R in part 1. We know R is equal to, now we can see that it starts at 100 and each new term is 4% less. So our R is going to be 1 minus P on 100, or 1 minus 4 on 100. And when we work that out, that gives us 0.96. Part 2 says, state correct 2 decimal places the first 4 terms. Well, we know what the first term is. The first term is 200. Okay, and then we are going to multiply by 0.96 to get 192, times by 0.96 again, and we get 184.32, and 0.96 again, and we get 176.95. All right, what about the next one? let's work out our R to start off with. And this time we are looking at it's more than. Remember, this one was less than. So R is going to be 1 plus P, and my P is 12 over 100, which gives me 1.12. So that's my R value. Let's find the sequence now. Well, we know that it starts at 500. And this time we are going to multiply by 1.12. So we would expect our values to be getting bigger. And when I multiply by 1.12, I get 560, and then 627.2, and my last one times by 1.12, 702.464. Now I want it to 2 decimal places, so I'll just do 0.46. Park Ranger Megan has been working on a project to increase the number of rare native orchids in Wilson's Promontory National Park. At the start of the project, a survey found 200 of the orchids in the park. It is assumed from similar projects that the number of orchids will increase about 18% each year. All right, so underlining the important information in that question, we have 200 orchids. Obviously, that's what we're starting with, increasing by 18%. In part 1 here, we are asked to find the first term, A, T1 or A, and we can see, hopefully from the question, that there were 200 at the beginning. It then asks us to find the common ratio. Now remember, we're dealing with the percentage change here, and it's an increase, so it's 1 plus 18 over 100, our percentage over 100, which gives us 1.18. So in part 2, we're just trying to come up with a generic rule because we don't know what year we're actually looking for. So find a rule for the number of orchids at the start of the nth year. Well, we do know that our rule Tn is equal to AR to the power of n minus 1. And in this case, we do know that A is 200. We know that R is 1.18, and N is pretty much what we are looking for. So our generic rule here, Tn equals 200 times R, which is 1.18 to the power of n minus 1. So it really means now that if we knew what year we were talking about, we could just substitute it straight into that rule and come up with an answer. And part 3 is asking us that exactly. How many orchids are there in 10 years' time? So that means that that is our n value. So our n, we know here that n is equal to 10. Okay, we know that A is 200 and we know that R is 1.18. We've already got a rule up here. So therefore T10 is equal to 200 times 1.18 to the power of 10 minus 1, or 9 if you like. And when you put that into your calculator, it comes out to be, now we want it to the nearest whole number because you can't have a piece of an orchid. So to the nearest whole number, that comes out to be 887. That should be approximately, I guess. So there will be about 887 orchids in 10 years' time, according to this model.